All right, let's see how well we understand the concepts of solutions, roots, zeros, x-intercepts, all that stuff. Still in section 7.1, some practice questions now in our 83rd installment here. All right, so here we have 4 quadratic functions. It says which function has 2 equal real zeros. Let's see if we can remember what would make that happen. We'd get 2 equal real zeros. Remember, we had 3 cases. We could have 2 unequal, 2 equal, or 2 unreal, or 2 no real zeros, we said, sorry. So if we have 2 equal real zeros, well, this is a graph of a quadratic function that would have 2 x-intercepts. So it would have 2 unequal real zeros. And I remember the case, and you should remember the case where you have no real zeros if we don't touch the x-axis at all. And the case where we have 2 equal real zeros has to be one where the vertex is right on the x-axis. So we just touch it in that same spot. So we do get 2 roots, but they're the same number. So which one of these, basically what we're asking, would be a quadratic function with a vertex right on the x-axis? Let's see. Let's look at part A first. We've got a vertex there at 5 and 3. So over 5, up 3. These are what we call 5-second sketches. And it opens downward. So that would have 2 unique. That's out. No, sir. And the second one, well, part B, we got a vertex at over 5 and down 3. All right, so over 5, down 3. So over here, and it opens upward. 2 unique again. No good. Now, this one, you'd almost think it wasn't vertex form because it isn't. Well, it is, but it's also standard form. You could look at this as 2x minus 0 squared minus 3. See? So our vertex is actually going to be at 0 and negative 3. So if our vertex is over 0 and down 3, it would look like this if we open upward, which that one does for part C, and that would still have 2 different places where we cross the x-axis, so 2 unique real zeros. No good. What about the last one? Part D. In part D there, we've got a graph. Vertex is over 5 and up 0, and it opens upward. Aha! Just 1 x-intercept. So those are what we call 2 equal real zeros. D it is. The D's have it. What's next? Find the vertex of that function and determine the number of roots of that equation without actually solving. So we have a function and the corresponding equation. We have to find the number of roots of the equation without actually solving by looking at the vertex. Okay, so the vertex, standard form, so x equals negative b over 2a will get us our x coordinate. So in this case, that's going to be negative 8 over 2 times 2, and that's going to be negative 2. The y coordinate will be f of negative 2, which is 2 times negative 2 squared, plus 8 by negative 2, minus 7. So that's 8 minus 16 minus 7, which is, let's see, negative 15. So we have a negative 15, negative 2, negative 15 for our vertex. And if I'm not mistaken, this graph is going to open upward. Okay, so negative 2, negative 15. Say negative 2. This is very rough, of course, but that's all we need to get an idea. And the graph is going to open upward. So we're going to have 2 different places where we hit the x-axis. So 2 different x-intercepts for the graph, which means 2 unique real zeros and 2 unequal or 2 unique real roots. And that's what's going on here. That's it. Good question. Next. There is a subtle distinction. We went through all this before. But don't forget, roots, zeros, and x-intercepts all refer to the same numbers, but they mean different things in different contexts. It's all there. Good. So if the vertex is above the x-axis and we open up, or if we're below and we open down, nothing doing. No x-intercepts, no real roots. If the vertex is right on the x-axis, we get 1 x-intercept, 2 equal real roots. The vertex is above the x-axis and it opens down, 2 x-intercepts, 2 unique real roots. Don't forget it. Good stuff. See you next time.